welcome to our channel. So today's session we are going to discuss about 8086 addressing mode. The previous video we discussed about the flag register concept. Now we go for the 8086 addressing mode. Okay. So before entering the topic, first we know the addressing mode. So what is addressing mode? So addressing mode is to find the operand. To find the location of the operand is called as a addressing mode. Okay, so based on the operand place, you can categorize the types of addressing mode. There are three possibilities of mention the operand values. The first possibility is register. The operand is placed in the register. The second possibility, operand is placed in immediate. So directly applying the operand value in the instruction itself. The third possibility, memory. The operand is placed in the memory location. There are three possibilities of mentioning the operand. The first one is register, second one immediate, third one is memory. So based on that, we can categorize the types of addressing mode. So in this 8086 microprocessor, it categorizes the 6 types of addressing mode. The first type of addressing mode is register addressing mode. Then second one immediate addressing mode. Third one is memory addressing mode. So in this memory addressing mode, we can sub-categorize in 5 types of addressing mode. The first one is direct, second one indirect, third one based, indexed. Okay. The fourth type of addressing mode is port addressing mode. So in this addressing mode also, we classify into 2 types. First one is a direct addressing mode, second one is a indirect addressing mode. The fifth one is relative addressing mode. So in this addressing mode, you just check the condition. Whether the condition is true, it go to the loop, or otherwise just ignore the instruction. The last one is implied addressing mode. So it's also discussed in one by one. Okay. So before entering the topic, how to find the physical address. So you know the concept of how to find the physical address. That's very important. Okay. So in this concept, you can categorize the addressing mode easily. So it's a physical addressing mode. So in this physical addressing mode, first you find the segment address. So in this segment address, we can use the 4 type of segment. First one is a core segment, stack segment, data segment and extra segment. So in this segment address is a 16-bit value. So in this value, you just multiply with 10. So you can convert the 20-bit of address locations. So after converting the segment value into 20-bit of address location, you just add any one of the value or otherwise both the 2 values or 3 values based on the instructions. So you can add data segment value with base segment value, or otherwise segment value plus index value, or otherwise segment plus these 2 values, or segment plus these 3 values. So based on the type of addressing mode, you can add the segment value with the base or index or displacement or both the values, all the values. Okay. So now we discussed one by one. The first type of addressing mode is register addressing mode. So what is register addressing mode? So in this instruction, here we are posing the one example of the instruction, move AX, BX. So in the name itself, we represent in the instruction only mentioning the registers. So here we represent the AX and BX. The operand is stored inside the register, not a visible values. Okay. So in this instruction, move A, BX, AX, BX. So what is the function of this instruction? Just transferring the content from BX to AX. So BX register is a source point. So whatever value present in source, the content is transferred to AX. So it's a BX register. So BX is a 16-bit register. So in this register, I hold 410F. So it's a 16-bit value. So after execution of this instruction, whatever value present in BX, that value is transferred to AX register. So AX also 16-bit register. After execution 410F. So this value is stored in the registers. So register addressing mode only involving the register, not a data. So not a address location. The second type of addressing mode is immediate addressing mode. So in the instruction itself passing the immediate. So what is the meaning of immediate? So in this instruction you directly pass the data. So 16-bit data is passed in the instructions. So it's an example of immediate addressing mode. The example instruction is move cx, 5062. So it's a immediate data, so it's not a address location. In 8085 microprocessor, so it's considered as a address location. So in this address location, whatever data present, that data is passed to the register. But 8086 microprocessor, the immediate data is represented in a direct way. So in this instruction, MOV, not MVI. Okay. So MOV CX, 5062. So this 5062 is the immediate content. So this content is transferred to CX register. So after execution of this instruction, the immediate data 16-bit data 5062. So this value is transferred to CX register. So CX value now 5062. The third type of instruction is memory addressing mode. So in this memory addressing mode, you can categorize, we can split in 5 types of addressing mode. The first type of addressing mode is direct. So in the instruction itself, passing the direct address. So example of the instruction move cx, beta. So this beta is represent the address location. So immediate value or direct address location. For example, 4100. So this 4100 is a 16-bit value. So this value represent for beta. So this value sum with the segment register. So ds into 10. So whatever value present in ds, data segment, that value multiplied with 10. So after the multiplication, you can get a new value. That value sum with 4100. For example, I am taking it as the data segment value is 1000. So 1000 into 10, you can get 10,000. Okay, now the data segment value is 10,000. Just you add the 10,000 plus beta. So after addition, you can get 14,100. So in this 14,100 is a memory segment address location. So in this address location, whatever data present, that data is transferred to CX register. So it's a direct memory addressing mode. The next type of addressing mode is indirect memory addressing mode. So this is the example of the indirect move AX, SI. So in this instruction, we can pass the direct address location, but in this type of memory addressing mode, move AX, SI, the address value is stored in a index register. So indirectly mention the data. The example of the instruction. So after execution of instruction, what is the value transfer in AX? Just you sum the data segment into 10. So whatever value present in data segment, that value multiplied with 10 plus SI. So SI is a source index. So source index also having some 16-bit value. So that value sum with data segment, you can get a new memory location. So another location, whatever content is present, that content is transferred to AX register. So here also I made up the same value. Data segment value is 1000. So after multiplication of this value, you can get 10,000. The SI value is 0500. Just adding the two content. Now 10500. So in this memory location, whatever content is present, that content is transferred to AX register. The third addressing mode is based. So in this addressing mode also, the explanation is similar, but only one difference. So in this addressing mode example, we can use 1, 4. So one numerical value. So this value considered as a displacement value. So the example of the instruction is move AX, 4 BX. So BX is a base register. So after execution of this instruction, AX value data segment into 10 plus 4bx. So data segment value into 10, you can get the 20 bit of address location. So in this location, you add 4 plus bx. So whatever value present in bx, that value sum with 4 plus 20 bit. You can get a new location. Whatever content present, that content is transferred to ax. The procedure by same, but only one difference is you can mention the displacement value or without displacement value. But memory access point is same. The next type of addressing mode is indexed. So in this indexed addressing mode, the example of this indexed addressing mode is move ax, value si. So here also mention the displacement. So in the displacement in the form of label. So move ax, value si. So value is a displacement value in the form of label. So after execution of ax, so previous type of addressing mode I told ds into turn plus value. So value is a label name. So this label name also having some data. So this value 10,000 plus value is a displacement. I take this 4 plus si value 0300. Just adding the values 10304. So it's a new memory location. So in this memory location, whatever content is present, that content is transferred to AX register. The final memory addressing mode, the based addressing mode based on indexed. So it's an example of this instruction. So move AH, BX, SI plus beta. So in this instruction, you can use the 8-bit values. So AH. The source point is BX, SI plus beta. So in this instruction, the two registers are involved, base register and also source index registers. Just adding the two content plus beta. So it's a displacement value. So segment value here take as ds into turn plus in this instruction you can use bx. So base also involving. So bx value plus source index also involving si plus then beta. So beta is a displacement value. So in this instruction, these three values are involved. So these three values sum with the segment value. So beta. Just adding all the content. So whatever content present in ds, bx, si and beta. Just adding the content, you can get the new memory. So in this memory, whatever content present, that value transferred to AH, that 8-bit value moved to AH. It's a memory addressing mode. The next type of addressing mode is port addressing mode. So what is port? So port is a multiple number of wires. The combinations of wire is called as a port. Just carrying the data. So input data or output data. The port name is directly mentioned or indirectly mentioned. So based on that, we can categorize in two types. The first type of addressing mode is direct. The next one is indirect. The example of direct is IN. So in AL, 02. So this 02 is a not data. So it's not a data. So it's a port address location. So 02 is a port address. Okay. So it's a port. In this port address location is 02. So it carries some 8-bit value. So whatever value flow in the port 02, so that value is transferred to AL. For example 05. So 05 flow in the port. This 05 value is transferred to AL. So after execution of this instruction, so 05 is moved to AL register. The next one is indirect. So here also mention the instruction example in AL, DX. So AL is a destination point, source point is DX. So DX is a 16-bit register. So this 16-bit value represent the port. In which port you can select, that will get from DX. So DX is a 16-bit value. So this bit of value can take a port. So whatever value flow in the port, that value transfer to ALU register. So it's a port addressing mode. The next type of addressing mode is relative addressing mode. So in this relative addressing mode, you just check the condition. So here the example of the instruction is JNC start. So JNC for jump on, no carry. Whether the condition is true, so it move to start. So PC value plus start. So whatever value present in program counter, so that value sum with the start. So start is a label. So in this label having some data, some address location. For example 400. So it's a start label corresponding data. Just adding this data to program counter value. So you can get the new memory location. So in this memory location, whatever instruction present, that instruction will start and execute. The final addressing mode is implied addressing mode. So it's an example of implied addressing mode, CLC. So CLC for clear carry. So clear carry. So it's already we discussed in 8085 microprocessor. So implied addressing mode, the source point and destination point also same. Source and destination is same. So here the source point is carry register. So after clearing the carry, the result also stored in the same register. So it's a implied addressing mode. So this is the type of addressing mode. You just clear with the how to find the physical address. So it's very important. So in this concept is clear, you can easily solve the direct and indirect based index and based index addressing mode. So thanks for watching my channel. Please subscribe.